So there will be more questions starting on the next slide. I'll quickly show you. There's another one and a last question. Okay, so let's begin. A small disk, okay, is thrown vertically upwards at a speed of 15 meters per second from the edge of the roof of a building of height 30 meters. Okay, so we've got this disk. You know, I don't know about you, but I often go to the top of buildings and I just whip out some disks from the 1990s and I just start throwing them up. Boom, boom. Raining disks. Okay, so after 0.5 seconds, a small ball, B, is shot vertically upwards from the foot of the building. Okay, I like this question so far because a lot of learners get confused with this part over here. They don't know how to use the after 0.5 seconds part. So this will be good. From the foot of a building at a speed of 40 meters per second. Okay, so we've got some random stuff going on here, okay? So we've got some... So in the beginning, we've got someone who throws a disc upwards from this height over here at 15 meters per second. 0.5 seconds later, someone or something shoots a ball upwards at 40 meters per second. Okay, so the very first question says, explain the term projectile. So a projectile, so you know in class where you've got certain teachers, right, who they don't really care about any of your other subjects and they just so worried about, or they just concerned about their own subjects and they just keep giving you project after project after project. Well, those kind of teachers are called projectiles. Okay, that was probably quite funny. I like that one. Okay, but let's get serious. So what is a projectile? Let me go get well, let's explain it first. So a projectile, this is actually the definition. A projectile is an object that moves under the influence of only gravitational force. Okay? You could also say that a projectile is an object that is in free fall. Okay, so it's pretty much an object that's moving through the air like this, and there are no applied forces. Now, a lot of learners, they look at this situation here, and they're like, yeah, but sir, there is an applied force, because someone throws it upwards. Yes, I understand that, but you got to think about it after it leaves the person's hand. That is when we are looking at it. So once it's left the person's hand, the only force that is acting on that object is going to be gravity. Okay, we're not talking about the part where it's touching the person's hand. We're talking about once it leaves the person's hand and starts moving at 15 meters per second. Then it is a projectile, because a projectile is an object that moves under the influence of a gravitational force, or only a gravitational force. Okay, next question says, calculate the time taken by disk C to reach its maximum height. Okay, so we're definitely going to use equations of motion. Now, remember, when disk C gets to the top, we know that it will have a final velocity of 0. So I think, and they want us to work out time, so the best formula would be this one. Okay, now let's choose, we can choose whatever you want as positive, but I'm going to choose upwards as positive. Now the final velocity will be 0. Okay, so let's start here. So the final velocity would be 0, and we chose upwards as positive, sorry. The initial velocity is 15. What is acceleration? Well, remember, when it's a projectile, what is the only force acting on a projectile? Gravity. In which way does gravity work? Kevin, I can't remember. Okay, do me a favor, quickly get up from wherever you're sitting. Just jump. Just jump as high as you can. And then tell me, where do you end up? Well, you end up back on the ground. Why? Because gravity always acts down. Gravity always acts downwards, okay? So if we chose upwards as positive, then that gravity value, or that acceleration, will be a negative 9.8 because we chose upwards as positive, but gravity always acts downwards. And then the time is what we are trying to calculate. So now if we take this to the left, you would end up with 9.8 t equals to 15. If you divide by 9.8, you would end up with 1.53 seconds. Okay, so let's just put here 1.53. So that is the time to go from the where it started to get to the highest point. Okay, 1.53 seconds. Now it says, what is the height that it reaches above the ground? Okay, so don't worry about this part. We can just add 30 meters to our answer. Let's just take it from here, okay? Okay, so you can obviously go look at your equations of motion, but we definitely want to choose something that has displacement because they're wanting that. We already know the final velocity. We know the initial velocity. We do know the time, so you could even go use this. You could even go use this formula over here. I wouldn't use this one because maybe the time. I mean, yeah, I don't know. I don't like to use previous answers. What I like to do is be fresh. So I would use this formula. Because we, and let's choose upwards as positive. So we know that the final velocity is 0. We know the initial velocity is 15. We know acceleration is 9.8, but it's negative because it's acting down. We chose up as positive, and then delta x. We don't know what that is. Now be careful. Because we are talking about a final velocity of 0 and an initial velocity of 15, that means that we are only looking at this part over here. Right? So we're only looking at that part because that's where the initial velocity was 15 and the final velocity was 0. So the distance or the displacement that we calculate now is only that part over there. Okay, it's not the whole thing from the ground. So, right, let's go to our calculation. So 0 is equal to, what is that, 225? And then negative 19.6 x. Now, if you take the 19.6 over to the other side, okay, and if you had to get this by itself, you would say 225 divided by 19.6. And if we round to 2 decimal places, that would be 11.48 meters. But now that is just this distance over here. But they said, what is the maximum height above the ground? Okay, just add the 30 meters then. So we can just say that the final answer would be 11.48 plus 30, and that would be 41.48 meters. Now, I must tell you that if you had to go look at the memo, there's probably like 7 or 8 different ways you can do these questions. So remember, this is just the way I'm doing it. But if you have your own way, like some parts in the memo even make use of mechanical energy. Like these are all things that are fine to use. So this is just the technique I'm using. But that doesn't mean it's the best way. Not at all. It's just the way I felt comfortable with in that moment. This question says, calculate, here's where we're going to start using time. Now, this is a good question because a lot of learners, they mess up this part of a year. I've seen this a lot. Okay, so for 6 marks, calculate the time from the moment that disk C was thrown upwards until the time that ball B hits the disk. Oh, okay, so they're going to try hit the disk. I didn't even read that part. Okay, so this is interesting. So, okay, we've got different things in these sections. We've got distance, we've got time, we've got final velocities, initial velocities, for example. Now, you got to think about this carefully. I'm going to take all of this out right now. I'll leave those values here just so we've got them, and 11.48 meters. You need to think about this carefully. At the moment where B collides with C, what is going to be the same? No, they won't necessarily have the same velocity. We can't say that. We don't know what the velocities will be. What we do know, though, we don't even know that the times are going to be the same. We don't know. You can't. Yeah, but what we know is that, let's say C goes here and then goes here, and then ball B goes up here, and they collide at this point. Let's say that's where they collide. What we can definitely say is that the height above the ground for both objects should be exactly the same at the point where they are colliding. Their height above the ground should be exactly the same. Maybe they collide somewhere up here. Maybe they collide here. So there they're colliding. But once again, if you measure their height from the top of from the ground, that should be the same for both objects. That is the key you need to understand. So let's just make a little note there for ourselves. The distance above the ground will be equal. So, okay, so check this out. If you have the formula delta x equals to v initial delta t plus a half a delta t squared. Now we know that the distance above the ground will be the same for both objects. Okay? So for disk C, let's just go full in the information. So we could say that delta x, now remember when you're looking at disk C, when you say delta x, you're looking at this distance, we're looking at its displacement from here, okay? It's not from the ground, but don't worry, we'll fix that up soon. And so what we can say is its initial velocity was 15, and the time that it's in the air, we don't know. You might say, yeah, but Kevin, didn't we work out the time in the previous question? No, that time was how long does it take to reach its maximum height? But this question is a brand new question, and it's saying how long until the two objects collide. So we don't know what the time is. Now we're going to say half. Gravity is going to be negative 9.8, and then delta, or let's just say t squared. Okay, now for ball B, got to be careful here. Let's choose up as positive as well. So you could say, let's just say this is for disk C, and this is for ball B. Don't worry, we'll relate these two x's soon. Now, its initial velocity is 40. Now, here's where learners make mistakes. We know, and listen carefully, please. We know that if disk C is in the air for t seconds, then how long is ball B in the air for? It'll be 0.5 seconds less. A lot of learners put a plus here. But if you put a plus here, then what you are saying is that ball B is in the air for a longer time. But remember, the t value is how long is the object moving in the air. That is what t means. This t value is not how long since the very first object started moving. No, it's how long is that particular object in the air. So if ball C is in the air for 2 seconds, then that means ball B would be in the air for 1.5 seconds because it started later. So you minus, you don't plus, okay? If you said plus, just give it a little bit of thought, okay? And then here we're going to say t minus 0.5 squared. Right, now we need to somehow make some type of relationship with this part. You have two options now, okay? Because, okay, so let's just try to explain. This is actually a really good question. I'm very impressed with this one. So this part over here is this displacement over here, okay? Whereas this part is this displacement over here. Now we said earlier that when the two objects collide, their distance above the ground is going to be the same, okay? But the problem is that this one did not start on the ground, but this one did start on the ground. So what we could say is we could say that the displacement of C, okay, the displacement of C, or let me first tell you what we must not do. So this part here would be wrong, okay? So don't do this. Don't say that their displacements are equal, because that is wrong. Because let's say, for example, the displacement of C is 10 meters. Then what that means is that it went 10 meters upwards, okay? And then let's say the displacement of B is 10 meters, then that means it also went 10 meters upwards. So they would never collide. This object would be here and this object would be here, so it would never collide. So this is not the right way to do it, okay? Okay, now let me show you something interesting. Remember that this is a displacement value and this is a displacement value. So let's say the displacement of C, let's say that it goes up 7 meters. Let's say its displacement value is 7 meters, okay? How high is it above the ground? Well, you would add 30, right? So if its displacement value is 7, then the height above ground would be 37, okay? What if it goes up and then goes under the starting position by the time that ball B collides with it? Let's say ball B collides with it over here. Well, then the delta x C would be a negative value because you're ending up lower than your starting position, and we chose upwards as positive. So then you would get like, I don't know, -3. Let's say the answer was -3 for the displacement of the disk. Then how high is it above the ground? Well, you would say -3. You could still say plus 30, and that would give you 27 meters. That makes sense. If it's a 30-meter high building, and you ended up 3 meters down, then you would be at a total height of 27 meters above the ground. So what I'm trying to say is that to find the height of disk C above the ground at any moment, you can just take whatever its displacement value is, which is what we're getting here, and you just add 30, and that'll tell you how high it is above the ground. Okay, now we said that when the two objects collide, their distance above the ground will be exactly the same. So what we can say is the displacement that the object C undergoes, if you add 30 to that, then that is its distance above the ground. Okay, you can make that the same as object B's distance above the ground, but for that one you can literally just say object B's displacement, because object B is starting on the ground. So if object B has a displacement of 8 meters, then its distance above the ground is 8 meters. If it has a displacement of, 12 meters, then its distance above the ground is 12 meters. So we can just make this equation now. Now, all you do is you just go full in this over there, and you go full in this over there. And so if we go full that all in, we would have 15t minus 4.9. I'm just saying half of 9.8, and then I'm using that negative. T squared equals, plus 30 equals to the displacement of B, which is 40t minus 20, because I'm just multiplying that into the brackets, okay? Minus 4.9, and then t minus 0.5 squared. Okay, so let's just go simplify this a little bit further. 40t minus 20 minus. Now don't multiply the 4.9 into the bracket. You have to first get rid of these. Got to first do the double bracket. So it's t minus 0.5. T minus 0.5. Now, just to save us a bit of space, I'm going to go work this out quickly. And that would give us t squared minus 1t. You can go see what I mean. You'd get 0.5t, 0.5t, which would actually just give you negative 1t. And then plus 0.25 when you multiply those two together. Okay, so I'm just going to put that over there. Okay, let's carry on. So 15t take away, this is a really good question. Take away 4.9 plus 30 is equal to 40t. Take away 20, take away 4.9t squared plus 4.9t minus 1.225. Wow, okay. Now I see that these two are going to cancel. That makes life a little bit more interesting, or better. Now we're just going to take all the t's to the one side and all the numbers to the other side. So I'm going to take this one and this one. Actually, no, I'll keep those on the right-hand side, and I'll bring this one over to the right. Okay, so we're going to end up with, on the left, we'll end up with 30 plus 20, because I brought this one over, and I'm going to bring this one over, plus 1.225, equals 40t plus 4.9t minus 15t, because I'm bringing this one over to the right. And so if we're to now work this out, you'd get 51.225, and then on this side, we get 29.9t, and then if you divide both sides by 29.9, you get 1.71 seconds as our final answer. That was a good one, guys, but we still have another one coming up. Oh, and so if that was a bit of a confidence knock, I'm hoping it wasn't. Now we have to do what do we have to do here? A labeled sketch of velocity versus time graph. Okay, so let's just try to remember all of our important information. So we know that in the beginning questions, C reached 11.48 meters. I don't know if we're going to need any of that, and that took 1.53 seconds. The place where the two objects collide was at 1.71 seconds. Okay, so it says, on the same set of axes, sketch graphs of the velocity versus time for disk C and ball B from the moment that disk C was thrown upwards until B hits disk C. Label the graph as B and C. Okay, cool. So we obviously need a Y and an X. The Y will be called velocity, and that's measured in meters per second, and then our x-axis would be time, which is measured in seconds. Choose a direction as positive. I'll just choose upwards. Okay, guys, now check this out. In the very beginning, what was the velocity of c? It was 15. Okay, so you just go to the y-axis, and you just go to 15. Okay, now immediately, as soon as c starts going up, is it going to become slower or faster? Well, it's going to start slowing down until it reaches a velocity of 0, which is over here. It's got a velocity of 0. At that point, it would be at its maximum height, okay? Which we knew was 1.53 seconds. So let's go fill that in. Then, what would it do? It would start turning around and it would start going down. Now, we chose upwards as positive. So if it's now starting to go down, that means its velocity would become negative. So we just carry on like that. And then probably somewhere around here at 1.71 seconds is where it would collide. Okay, so let's stop there. And that would be at 1.71 seconds. So this is 1.53 and then 1.71. Okay, so that is object C. Let's go look at object B now. Now object B starts at 40 meters per second. So if we extend our y-axis a little bit, we can put a 40. But now be careful. It only started after 0.5 seconds. So at 0.5 seconds over here, that's where its graph must start. Okay? And then immediately, what would happen to the velocity of this object? Well, it would start slowing down. So we can just do that. And then just let it slow down until 1.71 over there. Don't make the two dots go towards each other, because then what you're saying is that their velocities are going to be the same wherever they collide. That's not what we're doing here. We know that object B's velocity is just going to decrease. These lines will always be parallel because those lines actually represent acceleration, which is 9.8 for all objects. And it would go there, 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 and then collide at 1.71 seconds.